Hello everyone, this is Ganesh and in this video I am going to explain about a few interesting things about the prime numbers. That means what are prime numbers and how many prime numbers are there below 100 and how can we find it. Is there any easiest method to remember those things, such kind of things. And very important thing is, if any number is more than 100, how do we know that number is a prime number? That technique I am going to tell you in this video, and definitely you'll get some idea about the prime numbers. And before that, everybody please share these videos and subscribe this video and likes and comments and everything we needed. Then I'll start now. Yes, here we have a few definitions about a prime number. First of all, we all know that 1 is not a prime number and it's not a composite number. So about 1 we all know that it's not a prime number and it's not a composite number. Now, how can we give the definition of prime number? The numbers which are not composite numbers, remaining all prime numbers we can say, but 1 is not a composite but it's not a prime number. So except 1, remaining all numbers which are not composite numbers, remaining all prime numbers. That is one kind of definition. And the other one is the factor of a number is always 1 and itself, then that is a prime number. For example, 3 I'll take. So 3 we can write 1 into 3. Is there any other factors are there? 1 and 3 only. These two are factors. So 3 is having a 1 and itself, that means 3. So only 2 factors are there. Then these kind of numbers are called prime numbers. Or otherwise, for example, 13 I'll take. 13 only 113s are except one table. Remaining table we won't get these prime numbers. That's the reason these are very special numbers and these are very useful to solve so many problems, so many topics. These are useful. That's the reason we have proper idea about the prime numbers. At least we have to know below 20 how many prime numbers are there. That is very important. And below 100 also very important. That's I'm going to tell you how many prime numbers are there below 20. Below 20 definitely we have to know how many are there and what are the prime numbers, also very important. And below 100 how many are there, that we have to remember. Okay, that's I'm going to tell you. And very important thing is below 20 how many prime numbers are there. So below 20 we have total 8 prime numbers are there. Below 20 8 prime numbers. These are very important. Definitely we have to by heart it, because prime factorization these are very useful, and finding HCF, LCM, very useful things. So these are all. So below 20 we have total 8 prime factors are there. That is 4 prime factors, prime numbers below 10, and again 4 prime numbers below 20. Total 8 prime numbers. These are very important. We just by heart it. There is no remember. We have to remember whatever it may be, either by hearting or whatever it may be. Any logic is not there. Just by heart it. Tables, how we are by hearting. Up to 20 tables we have to by heart the same thing. A few things we have to remember by hearting those things. So these are the 2, 3, 5, 7 below 10. 4 prime numbers are there. 11, 13, 17, 19 is again prime numbers below 20. Total 8 prime numbers are there. And even up to 100, below 100 total 25 prime numbers are there. So below 100 25 prime numbers are there. So how to find these prime numbers? And here we have one method is there, Eratosthenes sieve. Eratosthenes sieve we learn in 6th class. 6th class they introduced. By using Eratosthenes sieve we can find it, but it's not the easiest method to find. There is no easiest method. So by using Eratosthenes sieve we can find the prime numbers below 100. After finding that, just we have to remember or by heart those numbers. It is only for finding. First we have to find it, that's enough. That is Eratosthenes sieve. Yes, using Eratosthenes sieve, how can we find the prime numbers? Just I have taken here for understanding below 50 how many prime numbers, and how do we find those prime numbers using Eratosthenes sieve. So the method is, first of all we have to write 1 to 100, we have to write it. Just here I have taken 50 only, but whenever you want to find below 100, so 1 to 100 you have to write in this manner, and you can draw the box also, tables also like this. So the tables also you can draw it, no problem. So after writing 1 to 100, then first 1, already we know that 1 is not a prime number, we know, so just cancel it. And the second thing is 2. So 2 circle it, that is you have to circle 2. Then what are the multiples of 2? All the multiples we have to cancel it. So multiples of 2, all even numbers we can cancel it. Here see 4, 6, 8, 10. So in this way all numbers we can, that means all even numbers are divisible by 2. These are all multiples of 2, we can cancel it. So after cancellation of multiples of 2, then next number is 3, circle it. Now multiples of 3 we have to cancel it. Multiples of 3 means 3 ones are 3, 3 twos are 6, already cancelled. 3 threes are 9, 9 we have to cancel it. Again 3 fours are 12, already cancelled. 15, cancel it. Again 17 is 17, 3 fives are 15, 3 sixes are 18, already cancelled. And 3 sevens are 21, and again 3 eights are 24, already cancelled. And 3 nines are 27, cancel it. 3 tens are 30, over. 3 elevens are 33, and 3 and here 3 13s are 39, and here we can use divisibility rule of 3 also. For example, divisibility rule of 3 is 4 plus 1, 5. 5 is not divisible by 3, and 4 plus 3, 7 is not divisible. 4 plus 5, 9, it is divisible by 3. 4 plus 7, and 4 plus 7, it's 11, not divisible. And here 4 plus 9, 13, it's not divisible. So these are all 3 multiples are over. After that, what is left? Next 5, just circle it. So now 5 multiples we have to cancel. 5 multiples means only 10s we have to check it, and 5s. So these all 25 and 35 will cancel, and 10s already cancel. 5 also over. After that, finally 7 circle it. So here then here we can stop it. Whenever 7 is there, already till here all the numbers cancelled anyway. All the numbers below 100 cancelled everything, because up to 7 is enough. So up to 7, if we complete all the multiples, then whatever numbers are left, those are all prime numbers. Just circle it. Whatever numbers left, just circle it, and those numbers are prime numbers. Whatever numbers left. Yes, here 49, 7 sevens are 49 also. 7 table also complete. First completed 7 also. After 7, no need to go for any other further number. So whatever numbers are left, those are all comes under prime numbers. Then list out 2, 3, 5, 7, all list out and write it one place. Then we have to by heart all those numbers. So in this way we can find the prime numbers. And one more thing here, one more small technique is there to remember. Below 100 total 25 are there, but 0 to 10 how many prime numbers are there, and 11 to 20 how many are there, total 10 tens are there. Between any two tens how many prime numbers are there. So by using this technique we can easily remember the prime numbers. For example, here DD, BBC, BBC, DA. DD means DD Doordarshan channel, BBC channel is there, and BBC 2 times we have to write, and BA it's a degree, Bachelor of Arts. So using this DD, BBC, BBC, DA, that we have to remember that one in our mind. So D is representing 4 and another D is representing 4. That means in the alphabets, D at which place A, B, C, D, fourth letter. That's the reason I'm right. B is second letter, and again C is third, and B again 2, B again 2, C 3, B 2, and A 1. So now if you add all these numbers, you will get a total 25. 4 plus 4, 8, plus 2, 10, plus 2, 12, plus 3, 15, plus 2, 17, plus 2, 19, plus 3, 22, plus 2, 24, plus 1, 25. So total we got it, total 25 numbers are there. And now how do we know? First one, for example, 0 to 10. 0 to 10, 4 prime numbers are there. 11 to 20, 4 prime numbers are there. 21 to 30, 2 prime numbers are there. And 31 to 40. So in this way we can find it. So this is the use of this technique. You can see here 81 to 90, only 2 numbers are there. Here 91 to 100, only 1 prime number is there. And 51 to 60, 2 prime numbers are there. So in this way we can remember how many prime numbers are there in between any two tens. So for example, 51 to 60, we have some confusion. Here you see 51 and 53 and 57, 59. These are all odd numbers. And one more very important thing is, generally prime numbers all are odd numbers only. All prime numbers are odd, except only one even number is there, that is 2. 2 even prime. This is 2 is even prime number, except 2 remaining all maximum odd numbers. So here total 51 to 60, 4 odd numbers we can find it. But in these 4 odd numbers, suddenly we don't know these are having any other than 1 and itself, any factors are there or not. We can't say directly. 51, which table? 51 is divisible or not? Is there any other factor is there or not? We don't. 53, 57, 52. So immediately, if we know this technique, yes, we can finalize, we can conclude. So 50 to 60, only 2 prime numbers are there. Then easily we can find it. What are the those prime numbers? For example, this one 5 plus 1, 6. It is divisible by 3. So other than 51 and 1 more factor is there. So it's not a prime number. And here one more thing is there. And 53, 57 is there. And 53 means 8. It is not divisible anyway. And 57, what about 57? 57 means 12. 5 plus 7, 12. Yes, it is divisible by 3. So this is also not a prime number. And finally 53 and 59 are prime numbers. So that is the use of this technique. Easily we can, even 91 to 100, how many prime numbers are there? Only 1. What is that? We can conclude that one also. Finally 91 is the prime number, only 1 prime number, because 93, 9 plus 3, 12, divisible by 3, and 97, 16. So 7 table we can cancel, 97. So that is the use of this technique. And this is the final topic, very important. So many members are asking how to how can we know a given number is a prime number. Just I will give 1 or 2 examples, easily you can understand. First I will take 53. 53 is a prime number or not? How do we know? 53 is a prime number or not? How do we know? Yes. So 53, the given number, for the given number we have to check here square roots are very important. Squares, we have to find the perfect squares. What are the perfect squares before 53 and after 53? For example, before 53, 49 is a perfect square, and after 53, what is that? 64 is a perfect square. 64 is a perfect square. So 53 lies between these two perfect squares, 64 and 49. That we have to find it for any number. That's the reason at least 20 20 squares we have to know properly, that we have to by heart it. And even in the future videos I am going to tell you what are the easy techniques to remember squares and squares also. And here 49 is 7 square we can write, 64 is 8 square we can write. Now 64 is the biggest number of 53, greater than 53. So 64 square root is 8 we have to select it. Now we have to check below 8 how many prime numbers are there, with that prime numbers we have to check 53 is divisible or not. That is the condition we are using here. So below 8 how many are there? 2, 3, 5 and 7. Total 4 prime numbers are there below 8. So with these 4 numbers we have to check 53 is divisible or not. Yes, here we can use divisibility rules also. Yeah, 53 is not divisible by 2 anyway. And 3 divisible to 5 plus 3, 8. It is not divisible by 3 also. And 5 means the last ones digit must be 0 or 5. No, 5 also not divisible. And 7 is 53. If we divide with 7, 7 sevens are 49. 49 means 4 is left. So 4 is left, and so it is not divisible by 7 also. So if it is not divisible by all these prime numbers, then it is a prime number. So this is the way of finding prime numbers. The given number is prime number or not. So one more example I will explain. Yes, 97 is a prime number or not. First what we have to do, find the perfect squares after 97 and before 97. What are that? After 97, 100 is there, it's a perfect square. And what is this? 81 is a perfect square. So 81 and 100 we have to take. Now here 81 means 9 square, here 10 square. Now the biggest number, the biggest square we have to select, that means 10. So below 10 how many prime numbers are there? 2, 3, 5, 7 only. So 4 are there. With these 4 numbers we have to check it 97 is divisible or not. Yes, 2 it is not divisible because the last number is 7. And 3, 9 plus 7 it is 16. So it is not divisible. And 5 means last number 0 or 5, not divisible. 7 ones are 7 and 2 is 97 is there. 7 ones are 7 and 27. 27 means 7 sevens are 29. So it is not divisible. 97 also not divisible by 7. So that's the reason 97 is a prime number. So prime number we can say. So in this way we can we can say the given number is prime number or not. Yes, I hope you understand well. I think you have a proper knowledge about the prime numbers, and please share and subscribe this channel. You will get more knowledge on this. Thank you very much.